This is the second part of our double angle and half angle formulas, and here we're discussing, as you can see, half angle formulas. So as we started the double angle formulas, what's meant by half angle? And a half angle formula is when we are looking at the sine or cosine or tangent of an angle divided by 2. That's where the half angle nomenclature comes from. So let's look how we would deal with these, or what we do to figure out what a half angle formula is. And as you can see here, we derive the half angle formulas for sine and cosine from the power reducing formulas. As we look over here to the right, recall that sine squared theta, the power reducing formula, is equal to 1 minus cosine of 2 theta divided by 2. Now, follow me through here, follow with me, that if we replace theta with alpha over 2, okay, if we replace theta with alpha over 2, then the above would read the sine squared of alpha over 2 would be equal to 1 minus cosine alpha over 2. And the reason for that, if theta is alpha over 2, 2 theta, which we have in the formula, would be the same as 2 times alpha over 2, which is just alpha. So the issue is that the angle that we have here with cosine is double the angle we have here. So if we have a alpha over 2 in this position, then double that would be alpha in this position. So now we have an equation, or a formula: sine squared alpha over 2 is equal to the fraction 1 minus cosine alpha divided by 2. So sine of alpha over 2 must be plus or minus the square root of 1 minus cosine alpha over 2. Now this is a big deal. It's a big deal because alpha over 2 is a specific angle, and so the sine of a specific angle is either going to be positive or negative. So notice in what I've written here, it's going to be one or the other, not both. It's either going to be a positive square root or it's going to be a negative square root. We don't really write plus or minus here. It's one or the other. Now, if we know that the sine of alpha over 2 is going to be positive, then that's what it depends on. We have to decide whether the sine of the angle alpha over 2 is positive, or we have to decide if the sine of alpha over 2 is negative. And that becomes work. That's one of the decisions we have to make when we use this formula. And we make that determination based on where alpha over 2, the angle, resides. Well, so, whoops, got ahead of myself. The half angle formula for sine is, as we see here, and it's just a repeat of what I have over there on the right. The thing about, the reason I put this in red is we make a decision on each problem that we do whether we're going to use a positive square root or a negative square root. Now, in the case of the half angle formula for, in the case of the half angle formula for cosine, we would use the power reduction formula for cosine. That is, cosine squared theta is equal to 1 plus cosine 2 theta over 2. And we would go through the same process. We'd replace theta with alpha over 2, and of course the angle in this position is double that theta. And so if we double alpha over 2, we have just alpha. And so we come to the conclusion that the cosine of alpha over 2 is either plus or minus the square root of 1 plus cosine theta over 2. And just as before, we have to make a decision problem by problem whether we use the plus sign or whether we use the negative sign. We do not use both. So again, just a resourcing or restating of the half angle formula for cosine. Now, in the case of tangent, half angle formula for tangent, we really have three possibilities. The tangent of alpha over 2, as you can see, is either plus or minus. We'd have to make a decision of a square root of 1 minus cosine alpha over 1 plus cosine alpha. Or we could use either one of this, kind of like the double angle formulas for cosine, aren't there? There's actually 3 different ones we could choose, and we use one that is most appropriate to us. Whoops. I've misstated this last one. It should say sine of alpha over 1 plus cosine alpha. We should not have, and it's my bad, we should not have this sine of alpha over 2 right there. That should not be in there. I mean, sine of alpha should not be in there. It's sine of alpha over 1 plus cosine alpha. So there's a summary, okay? The top two are the ones we use most frequently. We don't use very frequently the formulas for tangent of alpha over 2. So here we are with our first problem. And you can see it says we are to use a half-angle formula to find the exact value of A part sine of 22.5 degrees and B part cosine of 5 pi over 12. So let's deal with A part first. And in A part, we're to find the sine of 22.5 degrees by using a half-angle formula. So here's the half-angle formula for sine. So what we're thinking is the equation, the equating of 22.5 degrees with the angle we're taking the sine of. And so we're thinking of the 22.5 degrees as alpha over 2. So yes, if this is 22.5 degrees, alpha over 2 is 22.5 degrees. And so we would have alpha itself. See, we need to also know alpha so we can put it into the formula. And so alpha would be twice 22.5 degrees, which is 45 degrees. Now, here's something else we know. We know we've got to decide whether to use a plus or a minus. And since here we're going to have the sine of 22.5 degrees, and 22.5 degrees is in the first quadrant, we know the sine of any first quadrant angle is positive. Okay, so we have that out of the way now that we know that. So here we go. Alpha over 2 is 22.5 degrees, so we have sine of 22.5 degrees is equal to a positive square root. We made that decision. And it's the square root of 1 minus cosine of alpha, and alpha is 45 degrees, and all that's divided by 2. So now it's a simple replacement for cosine of 45 degrees, which is the square root of 2 over 2. Now, the only problem with what we've got is that we have a complex fraction under the radical. And so we're going to multiply the numerator and denominator by 2, and the reason we're choosing 2 is to get cancellation of this denominator in the numerator. So we got to make sure that we're having our 2 over 2 underneath the radical, but we're going to multiply the numerator by 2, and we're going to multiply the denominator by 2. And when we do, we have a 2 times 1, which is 2, minus a 2 times this fraction where the 2's cancel, leaving the numerator square root of 2. And of course in the denominator we have 2 times 2, which is 4. And then we use the simple idea that the square root of a fraction is the square root of the numerator divided by the square root of the denominator. And of course the square root of 4 is just a 2, so we have that written here. And of course the square root of the numerator would be square root of 2 minus root 2. So this root 2 is under this square root, and although that's a strange looking number, that is correct, and that's the way we would leave our answer. Now we move to B part, which was to find, I believe, the cosine of an angle 5 pi over 12. So this is similar to what we just did from the point of view that if we're going to use a half-angle formula, what we're thinking of is the formula that we have down here, cosine of alpha over 2, which means that the 5 pi over 12 is really our alpha over 2. And to use this formula, we need to know alpha. And so from our statement here, we would just, to find alpha, we would multiply by 2 on both sides. 2 times this fraction, of course, is alpha, and 2 times 5 pi over 12, if we simplify, is 5 pi over 6. So now we know alpha, and we're going to use this half-angle formula that I've written out. And so we have to decide in this formula, are we going to use a plus or a minus this time around? Well, of course, alpha over 2 is the 5 pi over 12, and the alpha is the 5 pi over 6. We haven't yet decided about do we use a plus or a minus. And here's how we make that decision. 5 pi over 12 is an angle between 0 and pi over 2. How do I know? Well, this is the same as 5 over 12 times pi. And 5 over 12 is smaller than 1/2, isn't it? So 5 over 12 is smaller than 1 over 2. That is, 5 pi over 12 is smaller than pi over 2. And that's really the issue. And of course, it's bigger than 0. And so this angle 5 pi over 12 lies in the first quadrant, and the cosine of any first quadrant angle is positive. Now, another part of this formula, we have a cosine of 5 pi over 6 inside the radical, and so we need to know what the cosine of 5 pi over 6 is. And that's what I'm doing here. First, I find out where the angle 5 pi over 6 is, and I decided that it's in the second quadrant. And then I look at that angle and say, well, that first coordinate is going to be negative, and in fact, it's negative square root of 3 over 2. By now, I hope that you have a lot of this committed to memory. This is something that you need to practice on so that you can determine the value quickly of things like cosine of 5 pi over 6. So now we have a replacement for the cosine of 5 pi over 6 in the formula. We've decided the cosine of 5 pi over 12 is positive, and cosine of 5 pi over 6 is negative square root of 3 over 2. And so we begin simplifying now. Of course, we don't need to write that plus in front any longer. 1 plus a negative is the same as 1 minus. And we're going to do what we did in the previous example. We're going to multiply under the radical by 2 over 2 so that we can get rid of this fraction square root of 3 over 2. So when we do that, you see that we multiply the numerator by 2, we get a 2 minus root 3. We multiply the denominator by 2, of course, we get a 4. And then we write the square root of a fraction as the square root of the numerator over the square root of the denominator. And once again, the square root of 4 is just a 2. So we have our final answer here. Again, it's a strange looking result, but it is in fact our answer. Okay, let's see what our next problem is. Oh, here we've seen problems similar to this in other areas, in other sections. We're told that the sine of theta is 1/6, and we're also told that theta is an angle between 0 and pi over 2. From that information, we are to find the exact value of the sine of theta over 2. Okay, we know the sine of theta, and we know where theta is, so we're asked to find the sine of theta over 2. Well, we can imagine immediately we're going to use the half angle formula for sine, which sine of alpha over 2 is either plus or minus. We make a decision of the square root of this expression. Okay, now here's a problem. We don't know the cosine of alpha of theta. We know the sine of theta. Okay, so we're going to take, and by the way, we do know. See, we got to stop and think, well, is the sine of alpha over 2? This is the first thing I'm looking at, but I pointed out that we don't know the cosine of theta, pardon me. We know the sine of theta, and so we're going to have to deal with the fact, we're going to have to use this information to figure out what cosine of theta is. But before then, we need to decide whether our answer is positive or negative. And since theta resides between 0 and pi over 2, then if we multiply all the way through by 1/2, what we'll end up with is that 0, 1/2 times 0, is less than 1/2 times theta, which is theta over 2, which is less than 1/2 times pi over 2, which is pi over 4. So the angle theta over 2 is between 0 and pi over 4, and since that's in the first quadrant, the sine of theta over 2 is going to be positive. Now back to deciding what the cosine of theta is. Okay, and over here on the side, I've started that. Now let's keep paying attention to over here on the side in this red box, and then we'll come back to the other side. We know the sine of theta is 1/6. So we use the Pythagorean identity that we have here, replace sine of theta with 1/6. So when we square that, we get 1 over 36. And then we subtract that 1 over 36 on both sides, and we get cosine squared theta is equal to 1 minus 1 over 36. And then with a little algebra, we can figure out that 1 minus 1 over 36 is 35 over 6. So cosine squared theta is 35 over 36. Cosine of theta itself is plus or minus the square root of 35 over 36. But theta is between 0 and pi over 2. And in the first quadrant, cosine will be positive. So we know the cosine of theta is positive, and the square root of 35 over 36 is the square root of 35 divided by 6, since the square root of 36 is 6. So cosine of theta is a positive square root of 35 divided by 6. So we take our formula, and in the place of cosine of theta, we put the square root of 35 over 6 right here. Okay. And as we've done before, then we want to get rid of this fraction in the numerator, so we multiply the numerator by 6 and the denominator by 6, and that results in a 6 times 1, that's this 6, minus 6 times this fraction, and that's just the square root of 35. And in the denominator, 6 times 2 is 12. Now, here we have to be a little more careful and notice that 12 is 4 times 3. So I could write what I have under the radical as 1/4 times this fraction. And the reason I'd want to do that is the square root of 1/4 is nothing more than 1/2. And so I could easily say, okay, what I have now, the square root of 1/4 is 1/2 times the square root of this fraction. And that's the fraction 6 minus root 35 over 3. So this would be our final answer. Okay, and our next problem, that's the end. That ought to give us a good workout then. We ought to be able to take these ideas and go further in our homework, and with a little practice, we'll be able to master this. Good luck on your homework.